Have you ever wondered how polymer degradation works? Or even how a mesh material with low degradation tendency compares with another material with high degradation tendency? Let's dive into the chemical composition and the chemical processes to find out more. Using polypropylene as an example, you will see that each polymer is composed of many repeating units called monomers that are linked together chemically, forming long molecular chains. The most important degradation mechanisms that lead to chain breakage are oxidative degradation, which is predominant in polypropylene, and hydrolytic degradation, which is predominant in polyesters. As chain breakage events increase, the polymer's molecular weight declines, resulting in increased brittleness and a loss of mechanical integrity of the material. The degradation process is accelerated under mechanical stress. This leads to the formation of microfissures, also known as environmental stress cracks. In contrast to other polymers, PVDF shows the highest resistance to degradation. The carbon-fluorine bond is one of the strongest single bonds in organic chemistry and reinforces at the same time the adjacent carbon-carbon bond. PVDF remains resistant to degradation, whether oxidative or hydrolytic. The PVDF filaments remain intact. PVDF remains stable even under mechanical stress. PVDF compared to a polymer with high degradation tendency. All Dynamesh implants are made of PVDF. PVDF is known for its excellent long-term stability and aging resistance compared to other materials.